All right, everyone. So I have to be out today because of a doctor's appointment for my daughter. So I wanted to send you guys a recording for 2.09 and 2.10. So first we're going to start with an EOC challenge question, just like we've been doing. Um, and on this, I was going to have you guys make a nice educated guess because you might not remember this. It's been a while since we did one like this from last semester. So I want you to look at it, and it says in the coordinate plane, segment PQ is the result of a dilation of xy by a scale factor of 1/2. And we want to know what point is the center of dilation. So there's a really cool trick for finding the center of dilation when it is not at 0, 0, and that is to connect the corresponding points and then see where those lines cross when you connect. So on here, PQ is corresponding to XY. So point P corresponds to point X, and this would be easier if I was in Blackboard, but we're going to do our best here. So there's point P to point X, and then point Q corresponds to point Y. So we're going to connect those. You might have to extend this out a little ways, and you'll see why. So we're going to continue these lines. I'm doing the best I can, honey. PowerPoint is not liking me. But we will continue, And if your line drawing skills were better than mine, you should see these lines crossing at a point -4, 0. That is the center of dilation. Again, if I was in Blackboard, I could use the line tool. And so if you want to try that, you'll be able to really see this. Those are some terribly not straight lines. This PowerPoint's not wanting to let me do straight lines. But you should be able to see there that those do cross. The point is you connect the corresponding points, and then wherever those lines cross, that is the center of dilation. It's that easy. So don't overthink something like this. If you see it on the EOC, connect those points, see where the lines cross, that's the center of dilation. But now we're going to move to talking to 2.09 and 2.10. There's our vision and mission statement. Code of conduct, be on time, be on topic, be respectful. And so today you'll be doing 2.09 and 2.10. We're talking about volume of a sphere and then volume ratios. Here's our learning targets. You'll be doing all of these things, which is really just finding the volume of a sphere and then talking about similar figures and how they compare. So here's a couple of definitions. The center of a sphere is much like the center of a circle, except for we're talking about a 3D figure. But it's the point to which all of the points on the surface of a sphere are equidistant. So this center right here, I could pick any point on the outside of this sphere and it would be the same distance to the center. And then the sphere itself is defined as a figure in space made up of all points equidistant from a given point. Again, just like a circle, but this is in space, not in a plane, so it's three-dimensional. And here's our volume formula for a sphere. 4/3 pi r cubed. So it says, what is the approximate volume of the sphere? Use 3.14 for pi. We're just simply going to plug in. Volume equals 4/3. Pi is 3.14. And then r is 4. Label in the picture here. Cubed. So we're just going to multiply now. Volume is equal to, and then you're just going to put this straight into your calculator. So you'll take 4/3. Go ahead and pause the recording or just do it along with me right now. See what you end up with. And you'll get 267.946, so that rounds up to 267.95 feet, and it's in feet cubed, cubic feet for the volume. That's it for that problem. Here's a question comparing a WNBA basketball with a regulation NBA basketball. So a WNBA basketball has a circumference of about 28.5 inches. An NBA basketball has a circumference of approximately 30 inches. And it says, what is the approximate difference in volumes between the two basketballs? Round your answer to the nearest hundredth place. So you need to work backwards on this one because they give you the circumference. Remember, circumference is equal to pi times the diameter. So let's look for WNBA. Circumference equals pi times the diameter. Well, the circumference is 28.5. That's equal to pi times the diameter. Let's figure out what the diameter is because we need to know the diameter to find the radius, and then we need the radius for the volume. So that's why we're working this way. Divide both sides by pi. So just grab your calculator and put in 28.5 divided by pi. And you should get about 9.07. We're going to leave it at about 4 decimal places for right now, since we are rounding kind of early on in the problem. So 9.0718. 9.0718 for the diameter. To get the radius, we're going to divide it by 2. So divide that number by 2. If you have it in your calculator, just leave it in your calculator and hit divide 2. See what you end up with. And you'll get about 4.5359 for the radius. Now we plug this in. Volume is equal to 4/3 pi. The radius again is 4.5359, and we cube that for the volume so we can get the volume. We're going to go ahead and do that now. And you should end up with 390.91 for the women's. And that would be in inches cubed. All right, so now we're going to repeat this process for the men's ball. And I'm going to pause this recording while I work it out. I want you to try this on your own and then play the recording when you're ready to check your answer. So your volume for the men's ball should be 455.93 cubic inches. And now to answer this question, to find the approximate difference in volume of the basketballs, we just subtract the difference, or excuse me, the men's volume minus the women's basketball volume. And we will get approximately 65.02 cubic inches. So it's a lot of work, but hopefully it didn't seem too difficult. It just takes a lot of time. We need to talk about the volume of similar figures. So we talked a lot about volume and we talked about volume of a sphere, but let's talk about the volume of similar figures in general. But before we get there, let's talk about the side lengths and the areas of similar figures. So let's just think about something here. If we have a rectangle with side lengths 2 and 3, and we dilate it by a scale factor of 5, let's think about how this affects the original and the dilated, or excuse me, how the original changes the dilated one. So let's say we have this rectangle. It's got side lengths 2 and 3, so it's 2, 2, 3, 3. So the perimeter there is just 3 plus 2 plus 3 plus 2, so it's 10. Now, if we dilate everything by a scale factor of 5, and this is not going to be drawn to scale, but I'm going to label it all correctly, that means we've multiplied all the side lengths by 5. So now we have 10 and 15, 10 and 15. Well, now this adds up to a perimeter of 50. So the perimeter just multiplied by the scale factor, right? 10 times 5, so it's just a scale factor. The ratio of the perimeters is just the scale factor. Nothing really changed there from what the actual scale factor is. Let's think about area, though. The area of the original would just be length times width, 2 times 3, which is 6. The area of the dilated one is much larger. The area of the dilated one is 10 times 15, so 150. What did we have to multiply 6 by to get to 150? You can find out by dividing 150 divided by 6, and that'll tell you what you multiplied by. You multiplied by 25. So think about that. That is the scale factor squared, right? It's not 5, but it's 5 squared, which is 25, that we multiplied by. Which kind of makes sense because remember the area is squared. The units are squared. We are multiplying length times width. It's not just a length. Okay, so think about that. That's where this comes from. The ratio of the perimeters is equal to the scale factor. The ratio of the areas is equal to the square of the scale factors. And we can take it one step further when we're talking about volumes. The ratio of the volumes is equal to the cube of the scale factor. So perimeters is scale factor, area is scale factor squared, and the ratio of the volumes is scale factor cubed. And the way we can use the units to help remember that is that perimeter is just distance. It's just straight up units. Area is always units squared. Volume is always units cubed. And it's the same for the scale factor. So hopefully that'll help it stick in your mind. The areas of two similar triangles have a ratio of 9 to 36. What is the ratio of their perimeters? So if the ratio is 9 to 36, for the areas, remember that means that scale factor squared. If I want to know the ratio of the perimeters, perimeter is just the scale factor. So I need to square root these numbers to figure out the ratio of the perimeters. Square root of 9 is 3. Square root of 36 is 6. Because we start with area. To get back to perimeter, you have to find just the scale factor, not the scale factor squared, which is what the ratio is for the areas. All you do is square root it. So you're just trying to get back to the original scale factor. You had the scale factor squared because it was area. Here's another example. The lengths of two similar triangles have a ratio of 2 to 8. So 2 to 8. The lengths. That goes along with perimeter, right? That's your scale factor. So that's your original scale factor, your ratio. The area of the larger rectangle is 84 meters squared. What is the area of the smaller rectangle? Let's take a step back here. If this is the ratio of the perimeters, or the length there, we have to square it to get the ratio of the areas. This is perimeter or length. This is areas. So we have to square it to get back to area. 4 to 64. Now I know the area of the large rectangle is 84, so we're just going to set up proportions just like we've been doing with other similar figures. But we're going to use this proportion that deals with area because we're dealing with area. The larger one is 84. We don't know the smaller one. We cross multiply and we solve. So we get 64x equals 4 times 84. And we get 336. We divide by 64 on both sides. And we get 5.25 for the area of the smaller rectangle. That would be in meters squared. So today, you should be finishing quiz 2.09 and 2.10. Be on the lookout for the help videos for those quizzes as well. Y'all have a great day, and email me if you have any questions.